Dimensional analysis is a tool that you can use to convert units easily. To understand dimensional analysis, you have to know about fractions. So for example, let's take these fractions here. 5 over 3 times 3 over 7. One way that you could look at this is to say 5 times 3, that's 15. And 3 times 7, that's 21. And you could say, well, what number goes into both 15 and 21 evenly? And naturally your answer is 3. So if you divide a 3 out of each of those numbers, you get 5 over 7. Now there's a quicker way to do that. Notice in the fraction 5 over 3 and 3 over 7, there's a 3 in the numerator and there's a 3 in the denominator. 3 in the numerator, 3 in the denominator. In math, if you have a number in both the numerator and the denominator, what you can do is divide that number out from each of them and change them to each a 1. So now what I have is 5 times 1, which gives me 5, and 1 times 7, which gives me 7. A much quicker way to do this. Let's take a look at another example. Here I have 9 divided by 3 times 13 divided by 9 times 7 divided by 13. If I look for numbers that appear both in the numerator and the denominator, I see that 9 appears in both the numerator and denominator, so I'm going to cross those out, change them to 1s. I also see that 13 appears in both the numerator and the denominator, so I'll cross those out, change them both to 1. Now if I take a look at what I have, in the numerator, I've got 1 times 1 times 7, and 1 times 1 times 7 is 7. In the denominator, I have 3 times 1 times 1, and 3 times 1 times 1 equals 3. So my answer is 7 over 3. This idea of canceling from the numerator to the denominator works not just for numbers, it also works for letters. If you look at this example, you'll see there's an x in the numerator and an x in the denominator. So we can cross those out, change them to 1. You'll also see that there's a y in the numerator, a y in the denominator, so I can change those to a 1. And what I'm left with is a z times a 1, which gives me z, divided by w times 1, which gives me w. So my answer is z divided by w. Not only does the process work with numbers and letters and variables, it also works for units. If you find a unit in the numerator and a unit in the denominator, they can cancel out just like the numbers and the letters did. To start a new process, we always do a problem that's very familiar to us, and I know that you can do this probably quickly and in your head, but I'm going to show you a process of dimensional analysis using a familiar problem. You're given 15 feet, and what I would like to know is how many inches is 15 feet. So the first thing you're going to do is take out the green sheet that I gave you in class, and on that green sheet, you want to look at the length section. And the reason I chose the length section is because we're converting feet into inches. So we're converting length into length. What you want to do is you want to see if there's any relationship between feet and inches. In other words, is there any conversion that tells you how many inches are in a foot or how many feet are in an inch? Something along those lines. And what you should see on your green sheet is there is a conversion from feet to inches. It tells you exactly that there are 12 inches in a foot. So as far as the path is concerned, you are going to be going directly from feet to inches because that is the conversion that is given to you on the green sheet. So once you've figured out the path, and the path will make more sense later on in this lecture, you start by writing what the given number is. In this case, again, remember the given was 15 feet. You take the given number and put it on your first fraction line. Now there is no denominator for this 15 feet, so what I like to do is just put a 1 there to remind me that the denominator is there, just right now there's nothing in it. Okay, now just like with the last thing, we want to get our feet to cancel. We want these feet to turn into inches. So currently, if I look, feet are in the numerator, and I need them to cancel out. So on the next line, where do I put the feet? Well, I put them in the denominator because then I know that the feet in the numerator is going to cancel out with the feet in the denominator. Well, let's go back to the path for a second. The path is feet to inches. So this conversion here is what I'm going to use to go from feet to inches. So in the numerator, I'm going to put inches. Now I look back at that green sheet again, and I say, well, what was that relationship between feet and inches? Turns out, 12 inches in a foot. So now I have to decide where to put the 12 and where to put the 1. Well, 12 is with the inches, so put the 12 with the inches, and the 1 was with the foot. So we put the 1 with the foot. One of the things I always like to do when I think I'm done with the problem is just double check my work. So just like before with the numbers, let's cross out the units that we see in both the numerator and the denominator. So I see feet in the numerator and in the denominator. So I can cross those out, and the only units that remain are inches, which is good, because if I think back to the problem, inches was what I was trying to solve for. So now it's just a matter of plugging it into my calculator. I'll take the 15 that I had here times the 12, so numerator times the numerator, and I get 180. And in the numerator still I have the inches. In the denominator, I have a 1 times a 1. 1 times 1 gives me 1. Now in my calculator, what I'm going to do is I'm going to take the 180 inches divided by 1. If I do that, I get 180 inches. And that's it. Let's take a look at another problem. In this problem, what we are trying to do is convert 50 inches into millimeters. This one's a little bit more difficult because when you take out the green sheet and you look at the length section, because inches and millimeter both measure length, you'll see that there is no conversion from inches to millimeters. So we have to be a little more creative. You know that millimeters is part of the metric system. And to convert from metric system to another metric system unit is really easy. You just have to use the right side of the green conversion sheet. Remember how to use the metric jumper. Basically, you count the number of spaces the two things that you're interested are apart. For example, let's say you want to know how many millimeters are in a centimeter. Well, milli is this dot right here, and centi is this dot right here. They are one space apart. So what that means is there are 10, in other words, a 1 with 1 0, millimeters equals 1 centimeter. What if I want to know how many centimeters are in a kilometer? Well, let's count the spaces. 1, 2, 3, 4, 5. What that means is there's a 1 with 5 zeros, 1, 2, 3, 4, 5. That many centimeters is going to be equal to 1 kilometer. So I can use that conversion in my dimensional analysis problem. So if I go back to my original problem and I want to go from inches to millimeters, what I need to do is I need to go from inches to some sort of metric. Because then once I'm in a metric unit, I can easily convert into the other metric unit of millimeters. What I see is that there's a relationship between inches and centimeters. So I know I can go from inches to centimeters. And it doesn't matter if you know how many centimeters are in an inch or how many inches are in a centimeter, as long as you know a relationship between inches and centimeters. Well, now that I'm in the metric unit of centimeters, I can convert to millimeters using the metric jumper that I have below. Okay, just like before, I start by writing my given 50 inches, and I put a 1 in the denominator since there's nothing there. It's kind of like a placeholder. Well, I'm trying to go from inches to centimeters. Currently, inches is in the numerator, so in order to get it to cancel, I'm going to have to write my inches in the denominator. Well, I've defined the path as going from inches to centimeters. So in the problem, I want to put my centimeters above the inches. Well, looks like I'm not done, so I need to draw another fraction line. And I need to go from centimeters to millimeters. Currently, centimeters is in the numerator, and I need it to cancel. So I'll put centimeters in the denominator of the next line. And since I'm trying to go to millimeters, I'll put millimeters in the numerator of the next line. And that is the first thing you do. Set up the units Don't worry about the numbers. After you're satisfied you've set up the units correctly, then you can go back and put the numbers in. Look back at the green sheet. Look at the relationship between inches and centimeters. It turns out there are 2.54 centimeters for every 1 inch. And what about centimeters and millimeters? To find out the number of centimeters in a millimeter or millimeters in a centimeter, just go back to your metric jumper. And you can see that centimeters and millimeters are 1 jump apart, so that means a 1 with 1 0 on it. And it's going to be 10 millimeters is 1 centimeter. So if I go back to the problem, I'll put the 1 with the centimeter, and I'll put the 10 with the millimeters. Now it's time to make sure that my units have all canceled out correctly. So let's take a look. I have inches in the numerator and inches in the denominator, so those cancel. I have centimeters in the numerator, centimeters in the denominator, so those cancel. The only units that I'm left with are millimeters, which is good, because that is what I was supposed to get. And this process can also be called unit analysis, not just dimensional analysis. Now what I would do is I would take my calculator out, and I would take all of the numerator numbers and multiply them together. So 50 times 2.54 times 10. And that would give me 1,270. In the denominator, I have 1 times 1 times 1. And 1 times 1 times 1 is 1. So my final answer would be 1270 or 1270 millimeters divided by 1, which would give me 1,270 millimeters. And that is my final answer. This next problem is tricky because there are many steps in order to convert from grams to tons. Grams and tons both measure mass. So if you look at the green sheet, look at the section that says mass. You should see some grams and you should see some tons. What you need to do is find a way to get from grams to tons. Now this concept is really tricky for a lot of students, so I like to think of an analogy to help me find that path. The analogy that I'm thinking of, it would be like Miss Campbell trying to get a note to one of her former students. Let's pretend that Miss Campbell wants to get a note to her former student Jessica. She no longer sees Jessica. So she has to find people who see Jessica who also see Miss Campbell who she can pass the note to. So when she looks through her schedules and she looks through the calendars, she notices that Jessica is in a class with Nick. And Nick is in a class with Allie. And Allie has Miss Campbell on her first block. So there is a connection between Miss Campbell and Jessica, but that connection is Miss Campbell has to give the note to Allie, Allie has to give the note to Nick, and Nick has to give the note to Jessica. Similarly, let's look at the grams and the tons. We have to find again a connection between grams and tons. When I look at the green sheet, I see that grams, there's a conversion between grams and ounces. And there's a conversion between ounces and pounds. And there's a conversion between pounds and tons. So this is the path that I can take to get from grams to ounces to pounds to tons. This is not the only path. There are other ways to get there, but this is one of the paths, and this is the one I'm going to show you how to use. So just like before, we start by writing our given 500,000 grams. And since there is nothing in the denominator right now, I'm going to put a 1 in the denominator. I am trying to go from grams to ounces. Currently, grams is in the numerator. So I'll write grams in the denominator of my next fraction bar. Since I'm trying to go to ounces, I'll put ounces in the numerator. Well, I'm not finished, so I need to add another fraction bar. I now need to go from ounces to pounds. Currently, ounces is in the numerator, so I will have to put ounces in the denominator in order to get it to cancel. And I'll put pounds in the numerator. And I still need to keep going. I need to go from pounds to tons, and currently pounds is in the numerator. So I'm going to put pounds in the denominator and tons in the numerator. Now's the time when you can go back and put the numbers in. So looking at the green sheet, I see that there are 28.35 grams for every 1 ounce. There are 16 ounces for every 1 pound, and there are 2,000 pounds for every 1 ton. What you want to do next is you want to go back and you want to cancel out the units that you find in both the numerator and the denominator. So I see grams in the numerator and in the denominator. I see ounces in the numerator and in the denominator. I see pounds in the numerator and in the denominator. The only unit that's left is tons, which is good because that is what I was supposed to solve for. Now it's all a matter of typing it into my calculator. So I take all of the numerator and multiply them together. 500,000 times 1 times 1 times 1. And I get 500,000 tons. Because I still have tons left. Now what I want to do is divide that by the numerator. Well, the numerator is, by the denominator. The denominator would be 1 times 28.35 times 16 times 2,000. When you do that, you get 907,200. When you take 500,000 divided by 907,200, you get 0.55, and we still have tons. And there's my answer.